Welcome back to the Deep Dive. And wow, this month we are diving into, well, a cosmic whirlwind, really. September 2025 was just an extraordinary month out there. We saw things that really challenged our perceptions, from amazing sky shows to some pretty wild drama deep inside our own planet. So our mission today, give you the ultimate shortcut to understanding the universe's September update. We've got a stack of sources, scientific reports, some really interesting online chatter. We'll walk you through the big discoveries, but also dig into some of those fascinating what-if scenarios and maybe some alternative ideas that got people talking. Okay, let's unpack this.
What's fascinating here is just the sheer amount and the variety of cosmic activity and how it all connects,
Yeah,
Next to how we understand the universe, which is always changing, September really gave us a lot to chew on, a mix of things we can see and measure, but also some really deep questions about our place in it all. It's a great example of how much we still don't know and how everything's kind of linked together.
absolutely. And speaking of things we could see, September kicked off by literally lighting up our skies. Some celestial shows that were just impossible to miss. First up, September 7th, many of us got that full lunar eclipse. You know, the blood moon, just spooky, beautiful. It really had people going outside, just looking up. Pretty awe-inspiring.
Oh, definitely. And these events, they're stunning, right? But also remarkably predictable. It really shows you the precision of celestial mechanics. The full lunar eclipse, like you said, that's when Earth gets right between the moon and the sun. Our shadow falls on the moon, and that reddish color, that sunlight filtering through Earth's atmosphere, the blue light gets scattered away, leaving the red to come through.
And then just 2 weeks later, the sky gave us another treat. September 21st, a partial solar eclipse. It really felt like the moon and sun were, I don't know, playing peekaboo with Earth, that little crescent sun.
That's right. A partial solar eclipse is when the moon just covers, well, part of the sun's disk from our viewpoint. It's another one of those powerful visual reminders of how precise orbits are. You really see gravity shaping how things move up there.
But then, just when we thought the sky show was over, a new player arrived on the scene, and here's where it gets really interesting. An unexpected visitor, Comet K1. It just burst onto the scene, bright enough to see with the naked eye from September 25th. And scientists are saying this isn't just any comet, it's rare, possibly from beyond our solar system.
Right, and that potential origin, that's incredibly significant. If we connect this to the bigger picture, an interstellar comet isn't just a rock, it's like a cosmic time capsule. It gives us this amazing free sample of another star system's beginnings. It directly helps us understand how planets form elsewhere. We can look at what it's made of, learn about the building blocks of other solar systems, stuff we just couldn't get any other way. It's like getting a postcard from another cosmic neighborhood.
Wow, a free sample from another star system.
Yeah.
But, let's be honest, when people hear interstellar visitor, they immediately think aliens, right? How do scientists deal with that natural human curiosity versus the strict science of what Comet K1 actually is?
Yeah, it's an important distinction to make. Mainstream science is pretty clear. No way is it an alien messenger. Comets, even interstellar ones, are, natural things, ice and dust. But it does raise that important question, doesn't it? How we interpret the unknown. That human impulse to find deeper meaning. It often leads to, let's say, imaginative ideas, which aren't scientifically proven, but they definitely spark curiosity. It speaks to that deep desire to find life out there. But, we need solid evidence for that.
Fascinating point. Okay, so from interstellar travelers, let's bring our focus closer to home, to Mars. Our neighbor Mars was really on fire this month, metaphorically speaking, thankfully. Lots of headlines, mostly thanks to NASA's incredible Perseverance rover. Just keeps going. Perseverance sent back the sharpest panorama of Mars ever. Ever. You could see hills 65 kilometers away. Looking at those pictures, it honestly felt like a movie set for, I don't know, Dune 3 or something. The detail was just wow.
Absolutely. And what's truly fascinating here is the engineering behind it all. Just incredible. The precision, the endurance of that rover in such a tough environment so far away. It says a lot about our technology. And those high-res images, they aren't just pretty pictures. They give crucial geological data. Scientists use them to look for signs of ancient life, maybe pick spots for getting samples later on.
And Perseverance didn't just sit there taking photos. It broke a record.
Yeah.
Drove over 400 meters in a single day. That was like a Martian marathon for a robot. It's just a number, 400 meters, but what does that actually mean for the mission?
Well, every meter it drives is a result of incredibly careful planning, and it gathers vital data as it goes. Ultimately, these record-breaking drives, they speed up our journey to Mars. Every rock it looks at, every kilometer it covers, it turns sci-fi into real engineering challenges and crucial data for, eventual human missions. It helps us understand the terrain, the hazards, what resources might be there for astronauts.
Makes sense. And of course, with a mission this big, you get the online speculation. Some people were saying Perseverance isn't just looking at rocks. They think NASA saw something unusual in the images and is keeping it secret. We do love a conspiracy, don't we?
Hey, yeah. The official answer from NASA is pretty straightforward. Nope. And while it's natural to wonder what might be hiding on another planet, the images and data, they're thoroughly analyzed and mostly public. That curiosity about life beyond Earth is strong, totally understandable. But extraordinary claims need extraordinary evidence, right? So far, it's found amazing geology, sure, but nothing supporting hidden structures or, life being covered up.
Meanwhile, back here on Earth, NASA's getting really serious about sending humans to Mars someday. They've got 4 volunteers living in total isolation for a whole year, simulating Mars conditions in a special habitat. It means no pizza deliveries, no TikTok, no seeing the outside world for 365 days. Sounds like, well, torture. Or maybe the ultimate reality show pitch. What's the actual value in putting people through that?
Oh, this kind of training is absolutely essential. The value is huge. The psychological challenges, the logistical hurdles of long space trips are just immense. It's not just about the rockets and landers, it's the human side. How do people cope with being cooped up, limited resources, communication delays, just being totally cut off? Understanding that is critical for making sure future Mars crews succeed and, frankly, stay sane. They study everything: crew dynamics, sleep, food, medical stuff. It helps us anticipate problems before they happen millions of miles away. These habitats are basically labs for living in space.
That really puts it in perspective. Easy to forget the human cost, isn't it? But if you thought space was the only drama queen, hold on. September had our own planet acting up. From our sun down to the very core. Yeah, our sun, usually just hanging out there, went a bit wild. Lots of activity, sunspots, big solar flares, and these things called coronal mass ejections, which led to several geomagnetic storms hitting Earth. We saw peaks around September 5th, 15th, and especially the 17th. And you could feel it down here. Lots of people reported headaches, and the Auroras, wow, they were dancing in places that hardly ever see them. Pretty amazing for those who caught it.
That's a classic space weather effect, exactly. Solar flares are these intense bursts of radiation, and CMEs, coronal mass ejections, are like giant burps of solar stuff heading our way. When those charged particles hit Earth, they can cause these geomagnetic storms, basically, temporary disruptions in our planet's magnetic shield. Cosmic static almost. And yeah, these storms can mess with Earth's magnetic field, which some studies link to headaches in sensitive people. And more obviously, they excite particles high up in the atmosphere, making those auroras way brighter and visible much further south than usual.
Okay, but here's the real head spinner. Earth's core. Scientists announced our inner core might be slowing down, maybe even stopping relative to the surface, or, get this, reversing direction. Sounds like science fiction. How do they even know this? What's the evidence? And why should we care about something happening so deep underground?
Right. And what's truly fascinating here are these deep, complex processes running our planet. How we measure something we can't possibly see directly. Scientists use seismic waves, earthquake vibrations, to basically X-ray the Earth's insides. By tracking how these waves travel through the core over many years, they can figure out how it's rotating. The inner core, it's a solid ball of iron and nickel spinning inside the liquid outer core. Its movement is driven by currents in that outer liquid part, think like boiling water, but molten metal. And the core's behavior does affect our magnetic field. This slowing isn't just, a weird fact. It's a big reminder that Earth is alive, dynamic, always changing, and its deep mechanics subtly affect things like GPS, even the length of our day, more than we realize.
You mentioned the lengths of the day, and it's already noticeable, right? Days are getting shorter. July apparently broke a record. The day was 1.34 milliseconds shorter than normal, which, okay, sounds tiny. But for things like satellites, navigation systems, even climate models, they actually feel that difference. It's like blink and you miss it for us, but for precise tech, it matters. Shows how connected everything is.
Exactly. That precision is key for so much of our modern infrastructure.
And, you guessed it, the core slowing down sparked a whole bunch of online theories, wild ones. Some people claimed if the core spins backward, time itself could reset. Imagine history running in reverse. Others worried it would wreck our magnetic field, letting in deadly solar radiation. What's the science say versus the imaginative speculation?
Okay, let's tackle those. The time reset idea. Scientists are very clear that's not happening. The core affects geophysics, not the laws of time. As for the magnetic field, yes, the core's dynamics do influence it, but immediate catastrophic danger from radiation tomorrow, highly unlikely. Our magnetic field is pretty robust. It changes over, geologic time, but a sudden collapse from these subtle core changes isn't expected. It's interesting to think about long-term planetary dynamics for sure, but this really highlights that important difference between scientific possibility and, well, pure imagination. Understanding the science helps appreciate the real mysteries without unnecessary alarm.
Right, separating the profound from the purely fantastical. Okay, and if all that wasn't enough cosmic craziness, September was also retrograde central. We had 7 planets appearing to move backwards in the sky. That got a lot of attention. Astrologers were calling it chaos mode. Scientists, well, they call it an orbital illusion.
Exactly. Scientifically speaking, retrograde motion is just an optical illusion, pure perspective. It happens because Earth orbits the sun at a different speed and path than other planets. So when we overtake a slower outer planet or an inner planet laps us, it just looks like it's moving backward for a bit against the distant stars. It's a celestial trick of the light seen from our moving viewpoint.
So, putting it all together,
Yeah.
what does this tapestry of events tell us? Well, one other bit of data from September was pretty amazing. Finding Martian rock deep inside Earth's mantle.
Yes. And if we connect that to the bigger picture, finding Martian stuff deep inside Earth points to a really turbulent shared history in the early solar system. It suggests Mars, and probably Earth too, had massive impacts or explosions way back when, flinging material across space. It's like seeing echoes of a violent past shared between planets. We're just starting to piece together how planets formed and evolved and how they interacted. It shows planets aren't isolated. They're part of this dynamic, interconnected system, trading rocks over billions of years.
It's incredible, like a giant, ancient cosmic pinball machine. And it kind of ties back to some of those other theories, doesn't it? Comet K1 as an omen, perseverance maybe hiding something, the core reversal being a time reboot. While scientists, rightly keep calm and focus on the data, these other ideas definitely add to the fun and the public's curiosity about it all. It shows that human drive to find answers, even if the answers are maybe beyond what science can currently explain.
It certainly fuels the imagination.
So wrapping up, September 2025 really gave us the full cosmic experience. We had those beautiful eclipses, that mysterious comet maybe from another star system giving us clues about elsewhere, Mars breaking records, pushing us closer to understanding, maybe even visiting our neighbor. And right here at home, our sun putting on a light show with auroras, while our planet's core acted like this weird, mysterious engine, maybe slowing down, maybe changing our days ever so slightly.
It's just a powerful reminder, isn't it? Our universe is constantly moving, full of incredible forces, and always revealing new things. And finding knowledge takes both careful observation and critical thinking. We need to approach information with balance and curiosity. Every new discovery often just leads to 10 more fascinating questions, which is the exciting part.
Absolutely. Whether you lean towards the science, the intriguing theories, or maybe a bit of both, the universe keeps us entertained and always learning. So here's a thought. What might you find if you looked a little closer? At the unexpected patterns, the celestial dance is happening all around us, every single day. Stay curious and keep exploring the cosmos with us.
Keep looking up, and we'll see you next time. Don't forget to subscribe.